Hello everyone. I warmly welcome you to this session on Python shaping the future of science and technology. I am Dr. Mehar and in this presentation we will explore why Python has become one of the most influential programming languages in the world. Today Python powers artificial intelligence, machine learning, scientific research, data analytics, cloud computing, automation, biotechnology, and many other emerging technologies. Whether you are a student, researcher, engineer, entrepreneur, or educator, Python provides the tool needed to innovate and solve the real world problem. In this session, we will understand Python's feature, application, career opportunities, learning roadmap, and its role in shaping future technologies. Let's begin our exciting journey into the world of the Python. Before exploring advanced applications, let's understand what Python actually is. Python is a high-level interpreted general-purpose programming language. It was designed with simplicity and readability in the mind. Unlike many programming languages that requires complex syntax, Python allows us to express ideas using clean and understandable code. For example, displaying a message such as "Hello World" requires only a single line of the code. Python offers several important features: easy to learn and use, interpreted execution, dynamic typing, open source availability, extensive standard libraries, strong community support. Because of these characteristics, Python has become one of the most preferred languages for beginners as well as experienced professionals. Today, Python is used worldwide in industries, universities, research laboratories, and technology companies. A common question among students is why should I learn Python? There are several compelling reasons. First, Python is easy to learn and beginners friendly. Its syntax resembles a natural language, making programming less intimidating. Secondly, the Python is highly demanded in industries. Organizations worldwide are actively hiring Python developers, data scientists, machine learning engineers, and automation specialists. Third, the reason is Python is increasingly versatile. It has been used in web development, data science, artificial intelligence, machine learning, automation, Internet of Things, cloud computing, scientific research. Fourth reason is Python has a massive global community. Thousands of tutorials, libraries, discussion forums, and learning resources are freely available. Finally, Python enables rapid prototyping. Developers can quickly test ideas, build product, and deploy solutions without spending excessive time writing complex code. Python truly empowers us to build the future. Now let's examine the key features that make Python so powerful. The first feature is its simple and readable syntax. Python code is easy to understand and maintain even in the large project. Second, Python is an interpreted language. This means code is executed line by line, making debugging and testing easier. Third, Python is cross-platform. Programs written on Windows can often run on the Linux and Mac operating system with minimal modifications. Python is open source. Anyone can download, use, and contribute to Python freely. Fifth reason is Python provides extensive libraries and frameworks such as NumPy, Pandas, Matplotlib, Scilab, SciPy, TensorFlow, etc. These libraries significantly reduce development time. Sixth reason is Python supports multiple programming paradigms, including procedural programming, object-oriented programming, functional programming. This flexibility allows developers to choose the best approach for solving the problems. One of Python's greatest strengths is its wide range of the applications. In scientific computing, Python is used for numerical analysis, mathematical modeling, simulation, and solving the differential equations. In data science and analytic, libraries such as Pandas, NumPy help process, clean, and analyze large dataset. In artificial intelligence and machine learning, framework like scikit-learn, TensorFlow, PyTorch are used to build intelligent systems. In deep learning, Python powers applications such as computer vision, natural language processing, autonomous vehicle, medical diagnostic. Python is also widely used in web development through Django, Flask, Fast API, automation and scripting, cybersecurity, Internet of Things, cloud computing, and develop educational research and financial analytics and business intelligence. This versatile explains why Python continues to dominate the technology landscape. At this stage, you can see the learning Python is not merely learning program language. It is the acquiring a tool that can open doors to numerous scientific, technological, and professional opportunities. Now that we understand the Python's application, let's explore the powerful ecosystem that makes Python so successful. One of the biggest reasons behind Python's popularity is its extensive collection of libraries and framework. For scientific computing, Python provides NumPy, SciPy, SymPy. These libraries help researchers perform numerical computation, symbolic mathematics, optimization, and simulations. For data analysis, Pandas and NumPy enables efficient handling of the structured and unstructured data. For data visualization, libraries such as Matplotlib, Plotly, and Seaborn help transform raw data into meaningful chart and visual insights. For machine learning, scikit-learn offers comprehensive collections of the algorithm for classification, regression, clustering, and predictive analysis. For deep learning, TensorFlow and PyTorch have become industry standard for building neural network and AI system. Python also supports web development through Django, Flask, Fast API, automation through OS, Shuttle, and Selenium, computer vision through OpenCV, and natural language processing through NLTK, Space CY, and transformers. This vast ecosystem allows developers to focus on solving the problem rather than reinventing existing tools. Python has become the language of the modern scientific research. One reason is its simplicity. Researchers can focus on scientific problems rather than spending expensive time learning complex programming syntax. Python offers a rich scientific ecosystem including the NumPy, SciPy, Pandas, SymPy, Matplotlib, scikit-learn. So these tools support everything from mathematical modeling to the advanced machine learning. Another important advantage is versatility. Python is used in physics, chemistry, biology, mathematics, engineering, economics, environment science, and social sciences. Python also provides excellent visualization capabilities, helping researchers create publication quality graphs and figures. Because Python is open source, researchers do not need expensive software license. Furthermore, Python integrates easily with the other languages such as C, C++, Java, Fortran, making it suitable for high-performance scientific computing. Through automation and reproducibility, Python helps researchers create transparent and repeatable workflow, which are essential for modern scientific investigation. Let us further examine why Python dominates scientific computing and academic research. First is ease of use. Python's clean syntax allows students and researchers to become productive quickly. Second, in integration, Python connects seamlessly with the dataset, cloud platform, high-performance computing system, and specialized scientific tools. This is cross-platform compatibility. Python programs can run on Windows, Linux, Mac operating system, and cloud environment. Fourth is the powerful libraries. Scientists can access thousands of specialized packages developed by global research community. Fifth is the community support. Millions of developers and researchers contribute to the Python's continuous improvement. Finally, Python has countless real-world applications ranging from genomics and climate modeling to artificial intelligence and financial forecasting. Python accelerates research, improves productivity, drives innovation, empowers education, and continues to shape the future of scientific discovery. A language's popularity reflects its practical values. According to the major programming language rankings such as TIOBE index and PyPal index, Python ranks among the most popular programming language in the world. This dominance is not accidental. Python's popularity is driven by strong industry adoption, growing demand in the artificial intelligence, data science application, scientific computing, educational use, large developers community. Major technology companies, startups, research institutions, and universities continues to adapt Python as the primary programming language. The trend clearly indicates that Python will remain a key technology for years to come. For students and the professional learning, Python is therefore a strategic investment in the future career growth. One of the most important tools in the Python ecosystem is the Jupyter Notebook. Jupyter Notebook is an open source web-based environment that allows users to combine code, equations, visualizations, and explanatory text within the single document. This makes it ideal for data analysis, machine learning, scientific research, teaching and learning, business analytics. Jupyter supports interactive computing, meaning code can be executed one cell at a time and a result appears immediately. It supports multiple types of cell, code cell, markdown cell, raw cell, output cell, etc. Researchers and educators particularly appreciate Jupyter because it promotes reproducibility and transparency. A typical workflow involves creating a notebook, writing code, running cell, analyze the result, and sharing finding with the collaborators. Today, Jupyter Notebook has become one of the most widely used tools in data science and scientific computing. One of the most exciting aspects of the learning Python is the vast range of the career opportunities it creates. Python professions are in demand across industries worldwide. Some popular career paths include just like software developer, web developer, data scientist, machine learning engineer, AI engineer, automation engineer, developer engineer, data engineers, research scientists, game developers. Organizations in software development, healthcare, finance, education, telecommunication, e-commerce, robotics, and government sector actively recruit Python professionals. As artificial intelligence continues to expand, the demand of the Python skill is expected to grow even further. Learning Python today can significantly enhance employability and open doors to high growth careers. Many beginners ask, how should I start learning Python? A structured roadmap can make the learning journey easier. Step 1 is learning fundamentals. Understand variables, data type, operators, input, output, operations, and basic syntax. In the second step, master the control flow. Learn conditional statement just like loops and decision making structure. Third step is study the data structure. Work with list, tuples, sets, dictionaries, and strings. This will help you to understand the data structure in Python. Fourth step is learn functions. Understood modular programming, parameters, return the values, and lambda functions. How we can define the user-defined functions. What are the applications of lambda function in Python? Okay, so these things will help you for the better understanding and applications. In the fourth step is explore object-oriented programming. Learn classes, object inheritance, polymorphism, and encapsulation. Okay, so this will help you to explore the object-oriented programming. Step 6 is exception handling and file operations. Develop the robust program capable of handling errors effectively when you have the data set or when you are running the code. Step 7 is modules and packages. Learn to use the built-in modules and third-party libraries just like NumPy, Pandas, okay, scikit-learn, etc. So when you have this type of skills, so this will again you are on the next level. Step 8 we have is the practice through project. If the skills which you have learned from step 1 to step 7, you will apply in the real prompts, build mini project and solve the coding challenges which you face. So This is essential and will enhance your skills, how you can write the Python codes, how you can use them. Next we have is the practice through. Step 9 is explore advanced topics. Study decoders, generators, regular expressions, multi-threading, and database connectivity. Most importantly, practice consistently build project, read documentations which are available on the websites of related to Python, its libraries, etc. Okay, so join developers community, stay curious and keep learning. Remember, expertise develops through continuous practice and applications. As we come to the end of this presentation, let us reflect on an important message. Python is much more than a programming language. It is a platform for innovation, discovery, and transformation. Whether your interest lies in the artificial intelligence, data science, scientific computing, research automation, cloud computing, cybersecurity, or software development, Python provides the foundation needed to succeed. The future belongs to individual who can combine domains knowledge with the computational thinking. Python empowers us to do exactly that. I encourage each of you to start coding, build project, experiment with ideas, and continue learning. Remember, code today, innovate tomorrow, transform the world. Thank you for your time and participation. Best wishes for your Python learning journey and future success. Thank you.